this is the continuation of the physics IGCSE Edexcel exam for the double award and the physics paper 1 for the GCSE in physics, a separate science. Okay, we were interrupted. I was interrupted by a phone call. I apologize. So I did part 1, questions 1 to 3. I didn't finish question 3, so we're going to start where we left off, which is question 3. Okay, so question 3, we did part 1, which is definition of current, part A, definition of current, part B, definition of voltage as 1 joule per coulomb, and then they gave us a circuit with 2 resistors in parallel. So the 2 resistors in the parallel in this diagram are R and S. Okay, so they're showing you the values of the current are shown here, coming from the battery. So this is a battery, and some of the current goes through R, so that means the rest of the current will go through S. Yeah, so the answer, the current has to split. What happens to the current here? This is one of the circuit rules. In parallel circuits, the current splits up. So if 0.4 amps goes this way, then 0.20 amps is left for the circuit here. Over here, the currents then join up again. So you have it adding up to the total back to 0.60 amps. Okay, so once you have that, you can continue to answer the questions. So my cat is being trapped in the room with me, and that's what you can hear in the background. So on diagram 1, it says, first of all, draw a voltmeter to measure the voltage of resistor S. So you've got to do this on the circuit diagram. So here's the circuit diagram. So you want it, the voltmeter goes in parallel, so the voltmeter goes across resistor S. Okay, so it brings its own 2 leads, and it can then measure the voltage across S. Now remember that anything in parallel is at the same voltage. Yeah, so if this is a certain voltage, resistor R and resistor S will be the same voltage as the bulb. That's what parallel circuits do. Okay, so that's another circuit rule. So you know about the circuit rule to do with current at a junction, and another junction, the same question, what happens here? Here they split up, here they rejoin. So there's a rule about currents in parallel circuits and a rule about voltage. Okay, so once we got this, the draw voltmeter for 2 marks, question 3, let's see how they are wording the 2 marks for the ammeter, the voltmeter. So the correct symbol, 1 mark, that you've drawn it in the correct place, and in parallel with S. So as long as it's in parallel with the resistor S on the diagram, you'll get your 2 marks. Okay. Then you deduce the currents. Well, I've already done that on the paper. So current for A1, let's remind ourselves where A1 was. It's the current going through S, or 0.4 goes here, so 0.2 amps goes there, and then A2 is when it rejoins. So 0.2 and 0.60 amps. Okay. So once you have those 2 values, you get 2 additional marks. So then it's talking about resistor R. So if resistor R, that's the first resistor, has a resistance of 11 ohms. Remember, the current through resistor R, that's how I've put it, was the one with 0.40 amps. So we know the resistance and we know the current. So it wants you to calculate the voltage across it. Well, voltage is another equation you need to know. So if you get 1 mark for knowing the correct equation, this is Ohm's law, or the equation for resistance. Okay, resistance normally is written as voltage over current. Yeah, it's the ratio of voltage over current, and it's when you're doing your formulae that you have to remember. It's good to remember how to put them in a triangle. Okay, so resistor is voltage over current, current is voltage over resistance, and voltage is resistance times current, or vice versa. So to work out the voltage across resistor R, you could put it there. Voltage across resistor R is equal to the current in R multiplied by the resistance of R. Okay, and that will give you 4.4 volts. So one for knowing the equation, one for putting the numbers in the right way around, and one for the answer and the unit's been given to you, 3 marks. Okay, so I've always taught my students, you put the equal signs underneath each other. What you're working out goes on the left-hand side. How you're working it out goes on the right-hand side. That is the most clear way of communicating mathematical answers. Then we go to the final part. Explain how the voltage across resistor R compares with the resistance the voltage across resistor R compares with the voltage across the battery. Well, we went through that. One of the rules is that they are the same voltage across R. Explain how the voltage across R compares with it. I don't know why I put there. The voltage across the battery. I should write this out in full, really. The voltage across the battery is, so all of this should be in your answer. The voltage across the battery is the same as the voltage across R because they are connected in parallel with no other resistance to share the voltage with. Okay, so we've revised circuit rules. We've remembered some electricity equations, and remember, there's no other resistance in that loop. And by the loop, we mean the path that the current can take. So in the R loop, it goes this way. There's no other resistance in this loop, so the loop would be there. That's a current loop. And there's no other resistance apart from R. Ammeters have no resistance. So whatever voltage this has, the voltage of the battery, equals the voltage of R, which equals the voltage of S, because they're all in parallel with each other and not sharing the voltage with anything else. Okay? So if you had a switch here, you could switch off this one. It wouldn't affect the first loop. Okay? So the second loop would be this one, the bottom loop. There's 2 loops in this parallel circuit. So we've now finished question 3. Oh no, we haven't. There's a part D. So part D, they've now got a battery, an ammeter, and a thermistor. So the circuit is a different circuit. So you've got a battery, a thermistor, so it's a temperature-dependent resistor, and an ammeter. Explain how the thermistor can be used to vary the current. So it's 3 marks. The resistance of the thermistor changes with temperature. That's 1 mark for realizing and communicating this, that you understand it. So that's how it changes. When the temperature increases, the resistance of the thermistor decreases. Okay, we call this negative temperature coefficient. Yes, so it's a negative correlation with the temperature. In such a case, remember the bits and brackets are not what they're looking for, but it's a way of helping you communicate what you're doing. The current in the circuit. In such a case, the current in the circuit will increase when the temperature increases. So those are your 3 points. You could do it vice versa. In other words, you could say when the temperature decreases, etc., the resistance would increase. So it's vice versa as well. As long as you got the 3 points consistently, these are the 3 points you need to make. Okay? So that's the 14 marks for the electricity question. And we continue on. Question 4. Okay? Question 4, it says a student investigates how much pressure she exerts on the ground when she's standing up. Okay? The weight of the student is 520 newtons, and the formula linking weight, mass, and gravitational field strength is required. So you've got to be able to state it. So if you can state it, you will get 1 mark for stating it. Okay? So there's 1 mark. I'll put it twice. And then the equation, I've made a mess of this, sorry, this is W, so that's the weight, this is the mass, and this is the gravity. So once you know the equation and you want to calculate the mass, you put your finger on the mass, and that's W over G. W is in newtons, G is given to you in the data sheet, remember, it's 10 for Earth, G on Earth is always 10 newtons per kilogram, which is the same as saying it's 10 meters per second squared if it's an acceleration. Okay? So gravity is the amount of weight to mass ratio which creates acceleration. So that's another thing you need to realize, because it's all connected. So mass is 520, the newtons that you're given divided by 10 is 52 kilograms. Now, because I'm explaining all this to you, the video will take longer than you necessarily need to be able to do the questions. So remember that you can actually listen to the video at 1.5 speed, which is what I do when I listen to YouTube videos. And then when you want to slow down or stop the video to copy out the correct way of doing something, you can pause the video. So I don't apologize for the fact that the video is long. I'm giving you a lot of revision help. So here the student is measuring the area of one of her feet. So she's kind of drawn a trace on this paper when it is in contact with the ground. So she's basically put the paper on the ground, stood and traced around her foot. She draws around her foot on a piece of squared paper. The grid's not to scale, but if you look carefully at the bottom of the paper, it says it's 2 centimeters by 2 centimeters. Okay? So what are they going to ask you? They're going to ask you to work out from the previous question. They want you to work out the pressure. Okay? So once you know her weight was 520 newtons, that the pressure is her weight, which is the force, over her area. So this is what we need. So the area we can work out by counting how many of these squares, 2 by 2 centimeters, are on this grid. So I've counted them out. I make it about 40 squares in total, I think. So I've shown, I put dots to count the complete squares, and the partial squares I've shown as adding up 39.5 there. This could be another half, which is roughly equal to that. So it's approximately, it's between 39 and 40 probably. Okay? As long as you show how you worked out the area on the grid, you'll get a mark for that. Okay? So the squares on the paper have a side of length 2 centimeters, which we've gone through. Estimate the number of the area of the student's foot in contact with the ground. That means you've got to work out how many complete squares. I counted 29 and about 10.5 squares, or approximately 11 from fragments. So it's between 39 and 40. So I put this as an approximate sign. Okay, what does that mean? It means it's an estimate. It means we don't know it that accurately. Now you remember each square, so you get 1 mark for doing this counting and showing how you've done it. And you have to realize each square has a 4 centimeter square, 2 by 2. Yeah, so you get 1 mark for that. And if you've got 40 of them, multiply by 4, you'll get 160. Okay, so in the mark scheme, as long as you've counted the number roughly and it comes to 40, as long as you're in that range, they'll give you that mark. So whichever value you use here, this will correspondingly change according to how accurately you estimated it. This is the equation I said they want you to use. Pressure is force over area, so there's another equation you need to add to your list to revise. Once you know all your equations, and you do lots of these papers before your exam, so it's now the beginning of April, so the exam will come mid-May probably, the first paper at the earliest. So once you know that, you can use the equation. Remember, the force is the weight in this case, force pushing down on her feet. Calculate the pressure of the student exerts on the ground when she's standing on both feet. Well, assuming her 2 feet are the same shape, then you multiply the 160 from here by 2, so that gives you a total area 320 centimeters squared. The pressure is then 520 newtons, divided by 320 centimeters squared gives you a value of 1.625 newtons per centimeter squared. I then put my answer to only 2 significant figures, because I don't think with the estimate that we've made we can be that accurate. So, and I'm not going to change the units, because changing the units into meters squared, centimeters squared, into meters squared, how would you do it? You don't need to, because you can put the unit that you've chosen to put there. And as it's only an estimate, 2 significant figures is, I think, what you should do. So doubling the area, 1 mark, calculating pressure, 2 marks, answer to 2 significant figures, 3 marks. Okay, they got 1.7, I've given 1.6. As long as you're between 1.5 and 1.8, they'll give you a mark. Okay. Next question is about motion. So it's linked to the topic on forces. So a bus is transporting passengers, and the bus can stop at certain points in its journey to let passengers get on and off the bus. So it doesn't really matter. The active part is the bus stops at certain points on the journey. The distance time graph here, distance in kilometers and time in minutes, is shown for this journey with sections labeled A, B, C, D, E, F, and G. And they want you to be able to interpret this graph, which is something I always teach my Year 9 students. Okay, so it's like an intro to GCSE, but it's easy to get it wrong. Remember, this is in kilometers, this is in minutes, so be aware of that. Give the letters of the sections where the bus is stationary. If the bus is stationary, it means the distance is not changing. Yes, when you're stationary, your position isn't changing, therefore your distance from wherever you're measuring it, the start of the journey, has not changed. So here's it stopped, here's it stopped, and here's it stopped. All the horizontal lines means the bus is stationary. So stationary equals horizontal lines. 1 mark for getting all 3. You need all 3 to get the mark. Okay. So the next part of the question is wanting to calculate the speed. Now, just where the horizontal distance, the speed is 0, so that means the steepness of a horizontal line is 0. If you want to have the speed, you need to have a slope, and the slope is the change in distance on the graph divided by the time taken. So they want you to do it for section C. So section C, I've drawn on my graph how much the distance has changed. It went up from 1.8 at the bottom of C. I've shown that there's 1.8 on this, the distance, and 4.4 at the top of C. So once I know the change in distance, I also need to know, well, it was from C between minute 5 and minute 7. So there's 2 minutes here, yeah? So the change in distance, that's how you write change in science. Change in distance, I always use S for distance, is 4.4 minus 1.8. So that's like the ups or the rise in your gradient. And this is the time. The change in time is 7 minus 5, and that's in minutes. Okay? So of course, that's what we're going to use. We're going to use this value and this value to work out the steepness, and the steepness is the velocity. Okay? If the steepness is 0, the velocity is 0, means stationary. Okay. So when you go back to it, you'll see that that's what I did on the graph. So I think that doing that on the graph will give me 1 mark. Putting the values in like I've shown on the graph will give me a 2nd mark, and then the answer 2.6 over 2 minutes will give me a value. So I could write it as 1.3, that would be 1.3 kilometers per minute, but we got to change it to meters per second, so that's what we got to do. So that's 2,600 meters, yes, and this is 120 seconds. So they want you to show that you can change kilometers into meters and minutes into seconds, and once you do that, you divide 2,600 by 120. I've already done the calculation, is 22 meters per second. So 1 for converting the units and 1 for correctly calculating the answer. The next part of the question is then an explain section. So remember, explain means you've got to understand it properly. Explain what the graph shows about the speed of the bus in section E compared with the speed of the bus in section A. Well, section A, we'll look at in a minute, is steeper, and section E is less steep. And remember, we said the steepness is to do with speed. So section A is this steep. It's not as steep as section C, which we've already calculated, but section E is very low in terms of steepness. The distance doesn't increase very much in the time, whereas this one is not as high as C, but much higher than E. So they want you to explain. Let's see the wording of the question. Explain what the graph shows about the speed of the bus in section E. So you say section E is less steep. Yes, so you need to put that into a sentence. I'm just showing you. Section E is less steep, therefore, and section A is steeper. It's faster. A steeper line means a faster speed, and a less steep line means a slower speed. Okay, So the idea that the bus is, the speed of the bus is greater in section A, that you got that, so the idea of the bus, the speed is greater in section A. So as long as you got that clearly communicated, you'll get 1 mark. And then you've got to say, because the line is steeper. Yeah? Line A is steeper. So 1 mark for showing that A is faster and B is slower, and you have to then, the second one is this second point, because line A is steeper. They want you to know that. Okay. And now they're giving you a velocity time graph for the third part. Okay. Another bus travels a distance 7 kilometers. Yeah. In a time of 14 minutes. So they've shown you the 14 minutes has been put on the axes for you. The bus travels at constant velocity. Constant velocity means it's not going to change. It's going to be a straight line. So you need to draw a straight line. Now you know that velocity is distance travelled over time taken. Well, if it's gone 7 kilometres in 14 minutes, it's going at half a kilometre per minute. You haven't got to change the units this time. You know that you want it to be at 0.5. So if it's travelling at constant velocity, and you just worked out that the velocity is distance 7 kilometres divided by time, 14 minutes, the average speed over that distance, constant velocity, average is the same as the constant velocity in this case, would be that purple line. So if you've drawn a straight line, you'll get 1 mark. Yeah? And you've drawn it at 0.5 and label that 0.5, you'll get your second mark. Okay? So that's how you get these marks. That's the end of the motion question. The next one of my students said this is the most difficult part that she needs help with. So this is good practice for you. A teacher makes a hot drink. He puts the drink in a cup designed to keep the drink hot. The photograph and the cross-sectional diagram, the both of them, show the cup with their features, special features. The special features are plastic lid. Plastic lid is a good insulator, but it also reduces heat loss by convection, which is obviously if the hot drink is up to there, inside there's your hot drink. This layer of air, yes, and say you've got some air there, it will heat up and it will try to rise, and that's called a convection current. Okay, so we're going to revise conduction, convection, and radiation. So a vacuum is 2 layers in there with a vacuum in between it. So it's basically no molecules in there, which makes it an excellent insulator. So it's not a good conductor. It's a poor conductor. It doesn't conduct because for conduction to happen, it's atom to atom vibrations. And then it's got a shiny, look at this, a shiny outer surface, and it's got a shiny metal inner surface. So this reduces heat loss. Both of these reduce heat loss by radiation. So we've got conduction, convection, radiation. Okay, those are the 3 forms that we have to analyze. So once you've done that, you come to the question. And this is 6 marker. So now they want you to explain how the design of the cup that I just explained keeps the drink hot. Refer to methods of energy transfer in your answer. And methods of energy transfer are conduction, convection, and radiation. Okay? So, first mark I put is there are a number of features which this in brackets means it's not the bits they're looking for. They're looking for slowing down energy transfer to the surroundings in the form of heat transfer, thermal transfer. Okay? Basically, heat always moves from hot to cold unless you put something to stop it. And then I'm going to let you stop the video and understand my questions because I think I've spoken enough. Okay, so I've put a section for conduction, yeah, how energy is minimized, energy transfer by conduction. Energy transfer, for example, is minimized for conduction by the vacuum as it contains no molecules or particles. And I've done similarly a section for the convection, yeah, and if there's only 2, so 3 marks here, 2 marks here, 2 marks there, and there was a general mark before. So that's how you get your 6 marks. I'll let you stop the video at this point, and you can copy down the answer. And this is just the more difficult part of physics. I think the mathematical parts, as long as you know your equations, you put the numbers in, you get your answer out, and you can get easy marks. These require a clarity of thought, a clarity of thinking, and a clarity of communication skills. And these are more difficult questions, always have been, and they're the same when you do advanced level science as well. If you can't explain it simply enough, it means you probably haven't understood the concept. Okay? So it's 3 bits to physics: the concept, the maths, which is used as a tool, and then the application of the concept to, say, technology. Okay, so I'll let you pause, and that means we've done question 6. We'll probably do one more question and then take another pause and do the final part of the question, the exam later. So question 6 is done. Let me just show you, if you want to see what they give the marks for question 6. I'll put it on the video so you've got a record of it. You can pause the video now before I move on to question 7 so you can see that's where I got the answers from. Yeah, but you've got to write it out in full. Okay, bullet points are fine as long as you don't miss the key points. Question 7 is about pressure. So this is Boyle's law. This is all about Boyle's law. If you haven't done this experiment, it relates pressure and volume together. Basically, as long as we keep the temperature constant for a fixed mass of gas at constant temperature, the pressure times the volume will be a constant. Yeah? So this is basically what Boyle's law says. So a student uses a syringe, trapped air inside. Okay? I didn't realize they'd written it. I wrote it again myself. So that's your trapped fixed amount of gas. So the fixed amount of gas is the trapped air, a fixed amount of trapped air inside, stuck between the piston and the pressure gauge. So once you do that, the diagram shows the apparatus used. Diagram 2 shows the pressure gauge, yeah, and when the piston is in its initial position. So say that's P1 V1, okay? So say this is equal to P1. So P1 is 24 kilopascals. You read it off the scale. That's all you've got to do for the first mark, okay? It's an analog meter, not digital. And the units are kilopascals. Remember, kilo stands for 1,000. So once we got the pressure, comes the real part of the question. Sorry about all my scribbles, but this is called active reading, okay? Once you do that, it means you're absorbing the information on the question. I recommend it that you're doing this when you're practicing these past papers. The piston is pushed in. Why? So that the volume of the trapped air inside the syringe is half. So the volume 1 goes to, the volume, second volume, will go into half of the initial volume. And since we call that V1, I'll change my values from V2 becomes half of V1. Okay? So it's telling us the volume is halved. The temperature remains constant. Remember I said that's a controlled variable? If you change 2 variables at once, the law does not work. You have to have a more complicated equation. Explain how the reading on the pressure gauge will change when the piston is pushed in. Well, if the piston is pushed in, the pressure will increase. Yes? I wrote decrease at first because I wasn't paying attention. The pressure will increase, or the reading goes up, because it says how the reading will change. So the reading goes up means the pressure will increase. If the volume halves, the pressure must double. Yes? So that's the second mark. Why? Because according to Boyle's law, pressure times volume must remain constant. What about microscopically? I've put here. So there's another way of getting this explain part. So this is the explain. This is what's going to happen. Okay? So explain how the reading will change. That means first you've got to state how it will change, and then you've got to explain it. So this is the explain part, is your final 2 parts. So one is by explaining that you know mathematically the Boyle's law, and it's on the formula sheet. So I put a little note for myself to show you where it comes on the formula sheet. So the Boyle's law formulae. So we're using, this is Boyle's law. Remember, I'm using a purple pen because in our school you need to make your corrections in purple. So you want them so to show what you've added to it. And my students, you need to show me that you have gone through the answers and corrected them. Okay, so purple writing, please. So pressure times volume is a constant, yeah? And then later on we're going to use how temperature and pressure also have another equation that's called the pressure law, okay? In this one, you keep the temperature constant. In this one, you keep the volume constant. In both of them, you keep the amount of gas constant. So I'm just showing you that the formula sheet does give you the more difficult formulae. So once you've done that, what about microscopically? Why does the pressure double? Well, because the volume is squashed, that the rate of collisions doubles. Sorry, I'm writing the rate twice. Rate of collisions, microscopically, of the molecules or particles. The rate doubles and the force doubles. That is a microscopic understanding. You probably don't need to say that it doubles. Okay? So the air particles collide more often. Rate increases. Let's not say doubles, because I don't think it may be a little bit more complicated than that. Rate increases, so the collisions occur more frequently. Another word they will accept is more often. As long as you got the often, frequently, or rate of, that means that you understand that. So this is an alternative to the third mark. Okay? Hopefully you can see that. Then it says the position of the piston is then fixed. Yes, now the volume is kept constant, so new control variable. So the volume is now constant, so that's the new control variable. So this is the second equation, where P1 over T1 is now equal to P2 over T2. And this is called the pressure law, which I showed you on the formula sheet. Okay? All right, so the air in the syringe is then cooled, so temperature goes down. State how the motion of the particles, so here we had a question microscopically, so they're now going into the microscopic element, aspect of it. How the motion of the particles changes, obviously inside the syringe, changes when the air is cooled. When the temperature decreases, yes, so I would put this in, even though I put in brackets means it's not on the mark scheme, means that's not the key point, but you still need to communicate, yeah? The speed of the kinetic energy decreases. As long as you got this bit, the speed or kinetic energy of the particles, yes, decreases. These are the key terms. Anything in brackets is just clarification. In a model answer, I would put the bit in brackets when you're revising. Explain how the pressure, so that's your 1 mark there. Okay, explain how the pressure of the trapped air inside the gas, remember it's a fixed amount of gas, changes when the air is cooled. Okay, refer to particles in your answer. So when the temperature decreases, the pressure decreases. 1 mark. Okay, when the temperature decreases, the pressure decreases in the same proportion as temperature. Why? It's the pressure law. Okay, so the ratio of change of pressure to temperature, let me just put that down, you can't see the equation. The ratio of temperature change to pressure change is what stays constant. Okay, so a certain the temperature changes by a certain amount, the pressure will change by the certain amount, as long as your temperature is measured in Kelvin. Okay, that's the only scientific temperature scale that we use. Remember, temperature in Kelvin goes to absolute zero, which is minus 273 centigrades. So you need to also revise temperature in Kelvin. Because at a lower temperature, yeah, the particles will collide with the container walls less often. So it's the same point we mentioned before, because this is about referring to particles. Okay, this is explaining how pressure changes when air is cooled. Pressure decreases. Why? Explain why referring to particles is there. Okay, because the particles will collide less often. With what? With the container walls. So the pressure is due to the microscopic collisions of these particles moving at potentially hundreds of meters per second. And as they are moving with less speed or momentum, also the force of each particle collision is reduced. So because they're also moving, the force of each individual particle is with a smaller momentum change, therefore a smaller force. And remember that pressure is the sum of all these microscopic forces divided by the area of the container walls. Okay, So this is a more difficult question for the 3 marks, 1 for there, 1 for there, and 1 for there. Okay, so remember you can download the mark schemes because these are old papers. Okay. Right, let's see how many questions we got left. We've got questions 8, 9, 10, 11, and the last question is 11. Okay, so I'm going to stop there and do a final video later on. So remember, if you've found this useful, make sure you like and subscribe and share it with your friends so we get as many viewers as possible, because we're trying to offer this as a service to as many students as possible to show the perfect way to write out your answers. So question 8 is shown for you, and you can have a look at it while you're still listening. Okay, so thank you very much for watching the video. If you're my students, make sure you do your corrections as soon as you've done this paper and you've gone through my video. Okay, hopefully see you all in the next video. Bye for now.